All right, so we're going to take some notes here today, and I've got a sheet of paper that would have normally been in our notebook. I took it out just to make it easier for me to work with the webcam and my screen recorder. This is going to be a page of paper in your notebook, especially if you have a composition notebook. But what we're going to do today is we're going to turn this sideways, and we're going to hold this like this when we take these particular notes, just because we need the space this direction as opposed to this way. So here's what we're going to do. We're going to talk about the seasons. We know the seasons are caused by the Earth moving around the sun. So I want to draw a little diagram here, and it's going to be pretty simple, but I need you to follow along with what I'm doing. And we're going to draw kind of about here in the center of the page, just a little circle, and this is going to be the sun. Here's my happy little sun right in the center of the page. Okay, now, this is all about the Earth and how the Earth's seasons are caused by its orientation to the sun. So I need to draw an Earth. Now, I want to be a little more careful with this now, and I actually want to draw the Earth a little bit bigger because that's what I need to draw on. I'm going to go find a nice round object to draw my Earth. I had a Gatorade cap, so about the right size. You could use anything where you could fit it on the page. We're going to have one here, one down here. I'm going to put one over here. And finally, one up here. So you can use any round object you want. Just make sure it'll fit on the page. So here's what we've got. We've got the Earth going around the sun, and we've got it at 4 different places. Now, the next thing we need to do is draw the equator. We've got to have the equator drawn. Remember, the equator is that line that is drawn halfway through the center of our Earth that separates into northern and southern hemispheres. So I'm gonna kind of eyeball it. Here's my equator. Now you'll notice I didn't draw the equator like this because the Earth is not like that. The Earth is actually, instead of being straight up and down, it is tilted at 23.5 degrees. So now I'm going to draw my equator about that same way. And we're not going to get a protractor out and measure, but we're just going to show that the Earth is tilted as it's moving around the sun on its orbit. All right, so there's my Earth. That did pretty good. That's close. Now, the Earth is divided into 2 halves. This is the northern half and the southern half. The northern half and the southern half. Now, we don't have 4 Earths here. All I've shown was the Earth at 4 different times. The Earth is moving around the sun. And I'm going to show that movement by an arrow. Earth goes from there to there, there to there, there to there, and finally back to where it started from. And the Earth does this every year. It starts off here, goes around the sun, and winds right back up where it started. Say January 1st. It's going to go around and be back at January 1st at some point. So here we go. We've got my Earth, and it's tilted as it's going around the sun. Now, what that does for me is it means that part of my Earth is tilted towards the sun at one part of the year, and at the other part of the year, it's tilted away from the sun. Well, if I'm pointing towards the sun or away from the sun, that greatly affects how much sunlight I get. And that's actually what causes the seasons. The temperature is determined by the sunlight. The amount of sunlight we get is determined by whether we're tilted towards the sun or away from the sun. Now, we live in the northern hemisphere. So when the Earth is right here, and the sunlight is hitting the Earth, look at my drawing. It seems like the sunlight is hitting the northern hemisphere a lot more than it's hitting the south. Now, granted, the sun's usually drawn a lot bigger, but you can see it. Man, the northern hemisphere, we're getting a lot of sunlight there. Versus when the Earth is over here, the sun is hitting the southern hemisphere more directly. Well, your temperatures are caused by how direct is the sunlight hitting you. So when the Earth is right here, our side of the Earth, our northern hemisphere, is getting the direct sunlight. When the Earth is over here, the southern hemisphere is getting the direct sunlight. Okay, so your temperatures are caused by how much sunlight you're getting, how direct that sunlight is. Your seasons are directly related to your temperatures. You guys know it's hot in the summer and it's cold in the winter. So therefore, your seasons must be caused by how much light you're getting and how direct you're getting that light from the sun. Okay. Over here. This is the day when our Earth is when our hemisphere is tilted most towards the sun. And I'm going to talk about everything in terms of us in the northern hemisphere. But you have to realize that the southern hemisphere is exactly the opposite. This day right here is called the summer solstice. That's the longest day of the year, the day we get the most sunlight because we are most tilted towards the sun. This is about June 22nd. It varies a little bit from a day or two here or there because of leap year, but that's about June 22nd. On that day, we in the northern hemisphere start summer. We don't start summer technically until June 21st. Summer doesn't start until our hemisphere is really tilted towards the sun and we're getting the most sunlight. Now, what about over here? Over here's another one day in the year. Every point on this curve, if we drew 365 points, each one of those is a day. Well, this over here is another day. But notice this is a day where we're tilting this way. We're looking over this direction. We're not looking at the sun directly. We're not getting the direct sunlight. The southern hemisphere is. This is called the winter solstice. It's about December 22nd, 23rd, somewhere around there. And this is where we start winter. It is the shortest day of the year, and this is the longest day of the year because we're getting the most sunlight and we're getting the least sunlight. So summer is when we are tilted towards the sun the most. Winter starts when we're tilted towards the sun the least, which makes sense. If we're pointing away from the sun, we're getting less sunlight. It's going to start to be, really cold because we're not getting much energy from the sun. Now we've got two other seasons in there. We've got summer and winter. We've also got spring and fall. If this is summer and this is winter, and this is how you have to figure this out on the diagrams, what season starts here? That's summer. That's winter. What's in between? That's fall. What makes this day special? Well, this is a day where neither hemisphere is tilted towards or away from the sun. Both hemispheres get equal sunlight. This is called the fall equinox. Equinox meaning sunlight, equal sunlight. Equinox, equal sunlight. This, for us, happens about September 21st or so. So this is coming up. We're getting ready to end summer and we will start fall. We start fall at this one day where neither hemisphere is tilted more towards or away from the sun. Okay. Equal sunlight. It also means we have about equal night and day, roughly, because you have equal sunlight. And the northern hemisphere gets the same amount of sunlight as the southern hemisphere. Now, the very next day, when the Earth is over here, now we're tilted a little bit more away from the sun than the south. We're in fall. They're in the opposite spring. So when do we do spring? Well, if this is winter and this is summer, and we're moving this way, this here is called the spring equinox. Or two ends on that. I do not know why. So that's the spring equinox. This is on or about, March 22nd, March 23rd, somewhere around in there. And that's about the time that we start spring. So you have to look at these diagrams to figure out, okay, here, we're in the northern hemisphere. We're tilting, we're leaning into the sun, so we're getting more sunlight. That's what summer is. Over here, we're leaning away from the sun. We're getting less sunlight, so that means it's going to be winter. Now, summer, fall, winter, and spring are not one-day events. These are the first days of each season. So that's the first day of summer. This is the first day of fall, where we start winter, our first day of winter, and we're in winter all the way till we start spring. And we're in spring until we start summer. So keep in mind that seasons are not single days. They are a range of days. So on these arrows here, if this is the spring equinox, the first day of spring, every day the Earth is traveling along this path. It's going this way. This is spring. Well, here we start summer. And every day along this path, we will be summer until we get to about September 21st. And at this one particular day, when both hemispheres get the same light, now we start fall. And every day, September 22nd will be fall. September 23rd is fall. October 15th, November 2nd, November 28th, December 1st, December 19th, December 20th. Everything up until this day is a fall day. Now, after December 22nd, what season is it December 23rd? Well, it's after the start of winter, so that's winter. So December 23rd is a winter day. January 10th is a winter day. February 2nd is a winter day. February 24th is a winter day. March 1st is still winter. March 19th is still winter. It doesn't change from winter to spring until you get to March 22nd. So this is all winter. Okay, now We've got where our seasons are happening. But what is physically happening on those days? What's happening to the Earth as it's moving from here to here? Remember, this is the longest day of the year, June 22nd. Over here in fall, you should know now by September 22nd, the sun's going down earlier. And you know, by the time we get to winter, the sun's going to go down really early. So all the way from here to here, we're getting less sunlight. Days are getting shorter. Okay? So in summertime, though, days are getting shorter. Over here in fall, days getting shorter. So, okay, we're getting actually less sunlight. Days are getting shorter because we're tilting more away from the sun. That should affect our temperatures, and it does. The question is, how does it affect our temperatures? This is where this gets a little interesting. As we go through summer, even though the days are getting shorter, what happens to temperatures as we go through summer? Which month is hotter, June or August? You should have said August. We know that to be true. Early summer is still okay. It's not that hot yet. So even though the days are getting shorter, our temperatures are increasing. Now, after we get about September 21st, now our days are starting to get noticeably shorter. We're getting less sunlight. Less and less sunlight. Days are still getting shorter, but now, by the time September comes around, temperatures start to go down. Notice about this is the time of year where it maybe kind of starts to not be so crazy hot here in Georgia. And that's exactly right. Temperatures are going down. Okay. This is the shortest day of the year. This is the day it is darkest for the longest. And sun goes down earliest at night because we're tilted most away from the sun. It's the shortest day of the year when we start winter. Well, that means the very next day, we're actually starting to get a little bit more light. So actually in winter, days get longer. Every day after the solstice, the day gets a little bit longer. You get a little bit more sunlight. And you know this, by the time we get to March, there's a lot more sunlight. The sun comes up earlier, goes down later than it did in January. But let me ask you this, though. Is Christmas our coldest time of the year? It isn't. It's a lot colder over here in February than it is usually in December. And why is that? The days are getting longer. I'm getting more sunlight. You would think I'm getting warmer, but it's not. Temperatures decrease as you go through winter. Your colder temperatures are usually like in February as opposed to December. So we get to spring. Now by spring, by March, now the days are starting to get kind of long enough that we get enough sunlight that now we really start to notice a change in temperature. that things really kind of sort of start to get warmer. So in spring, days are getting longer. And you really know what happens after March. After March and into April, into May, and certainly into June, which is still spring, you know what happens to our temperatures. Temperatures increase. Okay, so this is our guide to the seasons and what is happening in each season in terms of the temperature and the amount of daylight versus how is the earth oriented? Is it pointing towards the sun, or away from the sun? Our hemisphere pointing towards the sun or away from the sun. Hopefully you took good notes here, and you're going to have this in your notebook as a reference when I give you a diagram that's going to be computer generated probably next. And I'm going to ask you to make some statements about what's happening from here to here on this graph in terms of, what's happening to the light, what's happening to the temperatures. What day do we start winter? And keep in mind, everything for the southern hemisphere is exactly the opposite. When they start summer, we start winter. When they start spring, we start fall. Okay, so at this time, you should pause this, and I have a couple of practice questions that I'm going to throw at you to try to interpret what's going on at different times throughout the year.